So this is the first video for distinguishable object to distinguishable balls. So let's say balls to urns. And the first scenario is distinguishable to to distinguishable. So for all the videos I made, I want all you guys to think about the typical problem. Like you need to like memorize. If you didn't understand the process of solving this problem, I would recommend you to memorize one problem for each of the scenario, so you can so although like some cases you don't really understand the problem, you can understand like when compare the example you memorize with the actual problem. So let's just go through some example. So for example, a typical example for distinguishable to distinguishable is that if I want to ask you how many ways are there to distribute hands of 5 cards to each of the 4 players from the standard deck of 52 cards. So we have 52 cards, and we want to distribute 5 cards to each of 4 players. So so like the cards are distinguishable and the players are distinguishable. So the way we do that is to first choose 5 out of 52 cards to the first player, and then for the remaining 47 cards, that comes from 52 minus 5, we choose 5, and for the remaining 42 cards, we choose 5 for the third player, and for the remaining 37 cards, we choose 5 for the third player. Yeah, and one thing you need to remember is that we're not multiplying by 4 factorial, because we're not ordering these people. If the question changes to I want to distribute 5 cards to each of the 4 players, and I want these 4 players to show me my hand in order, and how many ways can that I need to multiply 4 factorial. But in this case, what I'm concentrating on is just like distributing cards to players, so I don't need to order player. So if you expand the equation, you will find that this is equal to, maybe like let's just expand it out. 42 factorial, 42 factorial, 7 factorial. So we can cancel these terms off. And finally, what remains is 52 factorial, 5 factorial, 5 factorial, 5 factorial, 5 factorial, 32 factorial. And that is very similar to the Mississippi problem. So let me see if I can find the Mississippi problem. Yeah, so Mississippi problem is essentially the same thing as this problem. Essentially, we're like for the Mississippi problem, we're essentially doing the same process of distributing indistinguishable to indistinguishable. What are we doing here? We are distributing the indistinguishable positions of letter to indistinguishable letter. So you can think of box M, I, S, and P. Then we have position 1 to 11. And we want to distribute the number 1, 2, 3 up to 11 into these 4 boxes. So the way we do that is we first from the first 11, we choose however many M is supposed to be. And from the remaining, we choose it for I. and then we choose it for S, and then we choose for P. So essentially, this would be 11 factorial, 1 factorial, 4 factorial, 4 factorial, 2 factorial. Yeah, or maybe like just if you didn't understand why are we doing that, just memorize these two examples that is related to the distinguishable to distinguishable. So if in the test there's a problem that is slightly different from this example, you just solve this